And then thank you for this question. When inf- evaluating infrastructure, understanding virtual machines and visualization isn't just about knowing the technology. It is about understanding how to drive efficient and solve real business problems. Break it down, a virtual machine or VM is essentially a software defined computer. It runs an operating system, an application just like a physical machine, but it is completely isolated from the physical hardware it runs on. There are three core components that makes a virtual machine work. First, it is the hypervisor. This is the software like player, VM or Microsoft and Hyper-V that sits directly on top of the physical hardware. Its entire job is to pool physical resources and dynamically allocate them. Second is the visual hardware. Because of the hypervisor, the VM is assigned its own visual CPU, visual RAM, visual storage, and visual network cards. The VM thinks this hardware is physical, but it's actually just a slice of the main server's resources. It's the guest operating system. This is the actual OS like Windows Server or Linux that runs inside the VM. Because of this isolation, you can run multiple virtual machines, completely different operating system on this exact same physical machine without them ever interfering or interrupting with each other. Now, how do we leverage this into a business setting? I look at it in these three strategic pillars. First, I talk about cost, reliability, and then speed. The first pillar is server consolidation. In traditional IT, companies often run application per physical server to avoid software conflicts. This means a server might sit there using only 10% of its capacity, which wastes huge amounts of power, cooling, and space. With visualization, we can consolidate dozens of those applications onto a physical server as separate VMs. For example, imagine a retail company has a physical server of a payroll, another for inventory, for and another for their website. Now, instead of paying maintenance and electricity for three physical boxes, we can turn those into three virtual machines on a single powerful server. This immediately costs hardware costs and slashes data center power bills. The second pillar is business continuity. In a purely physical environment, if a motherboard fails, your business application goes offline until a technician fixes it. With visualization, we use features like live migration. If a physical host shows signs of failing, we can move a running virtual machine to a healthy physical host with zero downtime to the users. Furthermore, because a VM is essentially a file, we can take routine snapshots and back them up to the cloud. So if an office experiences a flood or power disaster, we can spin those identical VMs up in the cloud within minutes, keeping the business running. The third pillar is development speed. If a software development team needs a clean environment to test a new product, traditional IT takes weeks to order and set up a physical server. With visualization, I can sign up a pre-configured VM template under 2 minutes. Once they are done testing, we delete and reclaim the resources. So ultimately, leveraging visualization transforms IT from an expensive, rigid bottleneck into an agile, resilient asset. It allows a business to scale rapidly, secure its data against disasters, and maximize every single dollar spent on hardware. Thank you, and I look forward to your thoughts on this approach.